All right, we'll continue our discussion in Chapter 6 of functional groups and long-chain hydrocarbons. We're going to focus on cyclohydrocarbon chains, that is, ring structures. These ring structures have the same type of nomenclature as the long chains. When we have 1, 2, 3 carbons in the chain, we have what's called a propyl group. All right, and if it's in a ring structure, it's called cyclopropane. Again, it's an alkane, just like the long chains. Single bonds only, saturated, and again, this is the smallest ring structure that you can form. Obviously, with only 2 carbons, you can't form a ring structure, but with 3, you can successfully bind the 3, and in each corner we have a carbon, and each carbon has their complement of hydrogens. Alright, so because it's not written doesn't mean they're not there. It's understood that that's how ring structures are written. The notation for long chain alkanes, general notation for alkanes is CnH2n plus 2. So we're trying to figure out what is the name of the chain if we're able to determine that there are 2 times the number of carbons, there are 2 times the number of carbons of the hydrogen plus 2, then we have an alkane. So we have a chain with only single bonds. However, with alkenes, if we're looking at the chains and we have what is the designation? CnH2n minus 2. Right. This tells us that our long chains of hydrocarbon contain at least 1 double bond. And the same applies for our cyclo compounds. We have a CnH2n, that we have a cyclo alkane. Alright, some of those examples are C4H8, C4, and then 2 times 4 is 8. We have butane, or actually cyclobutane, and that simply looks like a square, a rectangle, primarily a square, because the distance between each carbon and hydrogen is the same. C5H10, okay, is cyclo, 5 carbons, pentenyl, or pentane. And we can draw that structure like this. 1, 2, 3, 4, 5. And again, each carbon has a hydrogen. And as we get an increase in chain length from propane to butane to pentane, we go from a low boiling point melting point again to a high boiling point, high melting point, just like the long chains. Oh, let me do it. There you go. So here again is a cyclopentane, 5 carbons, each containing a hydrogen. Low boiling point, low melting point, high boiling point, high melting point, depending on the chain length. So as length or ring structure increases. All right. One of the things that we need to be aware of is that even though you have a chemical formula like C4H10, which would be what? All right, C4H10, 4 carbons, butane. Okay, so that's CnH2n plus 2. That's an alkane chain. So butane has 4 carbons, and we can write it like this: CH3, CH2, CH2, CH3. Bonds between the carbons. However, we can also write C4H10 in this manner: CH3, C, CH3, CH3. We still have 4 carbons, 1, 2, 3, 4, and we have 10 hydrogens, 3, 6, 9, 10. Alright, so what happened? We have the same molecular formula, but we have a different structure. So are these the same compound? No, they're not. We have to find the longest chain to come up with the name. So the longest chain here is obviously 4 carbons, making this butane. The longest chain here, regardless of how you look at it, 1, 2, 3, or 1, 2, 3, either one, you have 3 carbons in the chain. And what's a 3 carbon chain? That's propyl. And so this makes this compound propane. And of course we have to account for naming the functional group that's off of this long chain. And so we call it 2, because the methyl group, 2-methyl, is off of the second carbon, propane. And these are very different compounds, even though their molecular formulas are the same. Alright? These are what are referred to as structural isomers, because they are the same molecular formula, but different structures, chemical structures. Well, the same thing applies to ring structures. If we were to look at ring structures, we can also give a molecular formula, CnH2n H2N, like C5H10. Alright, so 2 times the hydrogen, 2 times the carbon number is equal to the hydrogen number. And this is a general formula for our cyclo compounds, CnH2n. Okay, what does that structure look like? It's cyclo with 5 carbons. Alright, if we have 5 carbons, 1, 2, 3, 4, 5. And in the cyclo, 5 carbon cyclo, 1, 2, 3, 4, 5, that would be cyclopentane. Okay. Now, does this have 10 hydrogens? Let's see. 2, 4, 6, 8, 10. It does. So that's cyclopentane. We can have another C5H10 with a completely different structure. You could have 1, 2, 3, and then 2 methyl groups. So we have 1, 2, 3, 4, 5 carbons, and 3, 6, 7, 8, 9, and 10 hydrogens. And these are, again, are structural isomers. But if we look at this, compound, what would we call it? We call it 1, 2, 3. So the 3 carbons in the ring indicate that it is a propyl group, propane. And if I number this, 1, 2, and 3. 1, 2, 3. Counterclockwise. I guess we could have gone 1, 2, 3 clockwise. This would be considered a dimethyl cyclopropane. Dimethyl cyclopropane. Alright, but those are structural isomers, the dimethyl cyclopropane and cyclopentane. Well, there's also another type of isomer called a geometric isomer. Geo having to do with its structure in space. And we're going to do what is this? This will be a part 3 and talk about geometric isomers and conclude that with a discussion of free radical formation. Okay? All right, we'll talk to you again.